Hello, hello. So, if you just got here, we are looking at the 10.5 notes today, and also the practice A is the one that we practice A and B for 10.4 is the one we passed out before we all got out. So, if you can have that ready, just in case you have some questions. I can quickly go over it as this is also due this week, okay? So have that ready. If you haven't printed out 10.5 yet, go print it out. We'll wait until everyone joins, okay? Should be a couple of minutes. The music is for just the waiting time because like all streams, I need to have some non-copyrighted music. All right, how's everyone doing? You want the Kahoot music? Yeah, I can turn on the Kahoot music. Later, maybe when you're working. So, great. So nice to see you all. You want to see my face or no? Just for a bit. I know most of you will say yes, but you probably think no, so I won't show my face. Joseph says okay. Sure, why not? That's a no. All right. Nope. All right, just to show that, seems like we're okay, but okay. Logan says no, so I won't disturb everyone. I'll show my fingers, all right? Right here. 2 fingers. Right. No. All right. Anyway, we'll take attendance once we settle in the notes for like a couple of minutes, and then we will continue. Can you guys hear me? Obviously, you guys can hear me. That's why you're responding. But can you guys see clearly as well? The stream looks pretty good on my end. Okay. So before we start, let's make sure that you know that all this live stream will be recorded. So if you missed or forgot what we talked about, you can go back in and watch it again, or you can watch it again anyway. Okay. Anyway, if you haven't subscribed yet, you should subscribe so that when we go live, you can track it right away. Not for any monetary purposes, because this is a non-profit organization here. Okay. So, by the way, before we start, do you have any immediate question on 10.4 Practice A, the one I passed it out? This is also available on School Loop under Note Guides. All my notes are there. So if you are missing any copies of anything that we need to turn in, it's there. Okay, I'm going to talk about what we need to turn in at the end of the class this week. Okay, that way we can pretty much take care of all the business in the end. But do we have any immediate question on this one? Well, if you can't figure it out right now, that's fine too. You can also send me the problems you want me to do. I will do them in the office hour from 11 to 12 every day. I stream every day if you haven't noticed. And yeah, I will prepare your problem if you send the problem to me, and then you can stream with me. Okay? All right, nobody asked anything. So let's go here. We all ready for this? We all got our copies. If you don't have a printer at home, no worries. You can always just follow along and then write free notes. Okay, that's fine. So you can just turn that in when you're turning it in. Okay. All right. So today we are going to be talking about angle relationship in a circle. So objective is this. Explore angle relationship in circle. But there are three types of situations mainly. There are tangent angles. There are inside angles, and there are outside angles. Okay, and today's is the 26th, right? Yeah. All right. How are we doing? All right. So the first thing I want to look at is the tangent angle. Why is it called a tangent angle? Because there's a tangent line that looks like this. Right? This is a tangent line, meaning that it only intersects at one point. And there's a secant line that cuts it through. Right here. Right? So it makes an angle here. So the goal is basically to find what that measure angle is. And to do that, we want to examine the arc that is cut by the angle, this arc right here. Now, the conclusion says that the angle is exactly half the arc measure. It doesn't really make sense in the beginning, so I'm gonna explain why, and it will make sense. Okay, so if you look at this, this is a circle, right? Whole circle. This is a straight line, right? You see how this line cuts here? It not only cuts the line into two parts, so this angle and that angle, right? Two angles. What do these two angles add up to? Type on the chat. What do these two angles add up to? Measures. Adi says 180. Matt says 180. Anyone want to disagree? See ya, Anjali. Ari, Brett. Okay. Bunch of 180. I think we all agree, right? These two angles add up to 180. Correct? Thanks, guys. So, now let's examine this circle right here. What does this circle total measure into? Type that in. This whole circle. Got a bunch of 360s. These are right. What? Right? So, now, you see this line? It not only cuts the circle in parts, it also cuts the line in parts, right? The line, the angle is related to this straight angle line. So the proportion should stay the same, meaning that this out of 180 is the same thing as this out of 360. So naturally, because you're cutting out of a bigger proportion, this part will be double this, because this total is 180, this total is 360. When you cut it evenly, this should be double of this. Does that make sense? Because the total is double, so when you cut it, it will be double. Doing okay? Alright. So, let's try a problem. Move this forward. Okay. So, who is BBDSJP? Sabrina, why you use BBDSJP? Yeah, go to switch your account. Or log in with your other account. Alright? Alright. So, the other one, so we're gonna look at this problem right here. So if you look at EFH, which is this angle right here, EFH, that's a tangent angle, right? So that should be what? Half of this cut arc, which is gonna be what? 130. Oops. 130 divided by 2, which is 65 degrees. So far so good? Right, because this is 65, because this arc is 130. You have to identify the arc it cuts. Okay. Alright. Next part is GF, which is this arc right here. Alright. What should this arc be in measures? Well, I know this is 122. What is this? Because if I find this, then I can find this, right? So what is this angle? How'd I get that? Isn't that like 180 minus 122? That gives you 58, right? So since this is 58, at 58, what should be the arc? Isn't that 58 times 2, which is 116. Okay, so take a look once again. This arc is cut by this angle, tangent angle. This tangent angle can be found by doing supplementary with 122. And once you get this is double. Okay. Kind of make sense? Yeah. So that's the first case. It's called tangent. Okay. Now we do inside angle. This inside angle is a little different from the other inside angle we've done before, which is we did two types of angles that are basically inside the circle. One is called central angle, which is from the center. If it's from the center, then whatever this angle measure, let's just say 100 degrees, then the measure arc is also 100 degrees. Right? Remember that? The other kind is called inscribed angle. So inscribed angle, if this is 100 degree, do you remember what would this angle be? Quick type. Do you remember? Type. 50. Remember? Inscribed angle. Very nice. Inscribed angle is half of the arc it cuts. I remember we went through these two types of angles that are inside the circle. Yeah, inside the circle. Now, this is neither of these. Agree? This is neither of these. So, why? Because this is not on the center, right? This is like random place inside the interior of the circle. So, naturally, these two arcs will be different, right? So, one will be larger, one will be shorter. Or one will be longer, one will be shorter. Or one will be larger in measure, one will be smaller in measure, right? We agree? Okay. Then, that means, however, how are this and this, these two angles related? How are these two angles related? Tell me their relationship and what does that mean? There's a name for it, and what does that mean? Vertical angles, very good. Vertical angles are congruent. Very nice, very nice, very nice. So, since that's the case, these two are congruent, right? But their arc that's related to either of them are different. This shows that this arc is not equal in measure with the angle measure, because otherwise it wouldn't make sense, right? Because these two are supposed to be the same, but the arc related to them are not the same. Okay? So, to get the angle measure, the idea is this. Hey, one is bigger, one is smaller, right? The actual proof is not like this. The actual proof requires a connection line here. And then I'll leave the rest to you. But the idea is to average the two angle measures. What does it mean by average? It means add together, divide by 2. Right? Half of this plus this. So, you'll do it. Half of measure AB and measure CD. Okay. All right. So, let's take a look at the problem. Okay? So, if you look at this, they first want, can you see? I'll move it over here a little bit. All right, so there are, you want to find AEB, right, which is here. So you have to first identify which two arc does it cut, right? So it's this one and this one. So it cuts like this. Yeah. Let me fix this line. It looks annoying. cuts like this, right? Since it cuts like this, you have this arc and this arc. You have to average them, okay? So this plus this divided by 2, okay? 1/2, 139 plus 113, which is going to be 126. Okay. This angle right here. Okay. Measure angle BEC is here. Naturally, how are these two related? Aren't they supplementary? So supplementary means what? Equals to 180 minus 126, right? Which is 54 degrees. 54 degrees. Yep. Sabrina, you're back. Glad to have you back. All right. The last scenario is outside angles. Now, there are 3 main ways to have outside angles, if you would take a look. First one, second one, third one. First one is when you have a tangent line and a secant line, which means one is like one point and the other one's 2 points. The other one, both are tangent lines. Last one, both are secant lines, which means it cuts through. So before we start talking about how you do this one, we need to first identify what arc does these 2 lines cut. So we're gonna do from the very right, okay, because that one's the easiest to identify. So if you look at the very right side, these 2 lines cut 2 arcs out. One is KM, one's JN, right? You agree? These 2 highlighted ones are the one that is being cut out. Okay, we're gonna use these 2 measures, okay? Similarly, you get this and this, right? These 2 arcs. And then finally, BD and AD. Okay, how are we doing? So once we get these highlighted, then we can identify, so every single one of them is the same exact thing when it's outside. It's half of large arc subtract small arc. So it'll be this minus this. Every single one, alright, is the same. Right? Just like that. Does that make sense? So it's very similar to the inside one, but the inside one is adding. Okay, so if the angle is inside, you add and divide by 2. If it's outside angle, then it's subtract divided by 2. Okay. Shall we flip the page? So I got a problem. Okay. So this one is straight up just applying the theorem. The angle that you want to find x is outside, like right here. So then to get the angle, you identify the arc that it is cut. So you have the large arc and the small arc. Right? So it's just straight up. Right? Do the 1/2, 200 minus 74, which end up being what? 1/2 of 126, which is 63 degrees. Okay. How are we doing? On the right side, it's a very similar problem. But we've seen this like 1,000 times already, right? Like, they give you a theorem, but they don't give you the actual, direct application, but they give you the answer, and they want to know the question, basically. It's the same thing as a midpoint problem. So your answer is found by doing 83 minus x divided by 2, right? The setup would be like that. Okay? And then you just find x, right? So multiply by 2 over first. That's what I would do. You can distribute first if you want, but distribute will give you decimal numbers, right? So x end up being what, 33 degrees. Okay? How good, how bad? Doing too fast, going too slow? Re-explain something? Talk to me. Am I doing okay? Are you doing okay? I'm fine. Thanks, Sia. It's good? Alright. If it's good, why don't you take a look at the problems that we have here? Oh, why are there different formulas? They're essentially the same formula. You mean like why have an outside one and an inside one being different? Or you mean like the outside angles are you talking about the outside angles, or some are inside, some are outside? They are the same. I'm just saying that there are 3 situations, but they're the same formula. They're not even different formula. They're the same formula. I just tell you there are 3 situations that you just need to get used to identify which parts to cut out parts. But as long as you get the cutout arc correctly, then there is the same thing. Okay? Don't think about it as 3. I think about it as 1. Does that make sense? Like, I think about it as 1 formula as well. It's an outside angle one, right? So that's just one situation. But there are different ways you can get the outside angle, but the way you calculate it will end up being the same, which makes sense. Okay? All right. So why don't we take attendance first? Okay? So everyone, if you are here, type here. Okay, don't type anything else, just type here. Okay, if you type anything else, then I'm gonna count it wrong. Okay. Hi, Ryan. You don't have to stay the entire time, Ryan, if you don't want to. I got you. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I only have 24 years. Let's see. 25, 26. Anybody see Keon? Okay. Oh, hi, Keon. Hello. Good. I missed that hello there, Keon. Let me recount again. Oh, so if you already put here, you can go ahead and start practicing with this, and I'll give you a couple minutes and then I'll go over this with you together. Okay, I'll give you a couple of minutes, or about 10 minutes or so, and then we will go over this. Okay, so let's see, 1, 2, 3. Wait. M is measure, so measure arc CE, which means this part. Okay, and see it, Hannah? I think need to put it like even higher, I think, if you want to see all the problems at once. You lift it. There. The CE problems bothers you. Oh, to clarify, the 25 is for this arc right here. Okay, this 25 is for this arc. Some problems definitely more interesting than others. The key for all these problems are making sure that you can identify the angle with the arc. But once you see it, they're not that difficult. But if you don't see it, it can actually be difficult. Matt, you're in the very right direction. I like that. Find angle D first. It's a very nice way to do it. So you need to find, like Matt said, you have to find angle CDE first. Okay? Find this angle, CDE, which is this angle right here first. Once you find that angle, you want to look at which arc does this angle cut. Okay? Angle CDE. Invisible number 2. It's for this angle right here. For number 3, 26. No number 2 in the second box. Huh? You mean like this is number 2, this is number 3, this is number 4? Kind of like that? Or I just didn't label them. Oh. All right. Let's talk a little bit. So, the first for future reference, if you're so sometimes word formatting is weird. So when you are actually printing it out, if you have issues with like missing parts of these things, I usually have a PDF version on uploaded as well. Print that version, because that version I already checked to see if everything is there. And PDF version does an alternate format. So in the future, if you have problems with like these parts missing, then just print the PDF version. Okay? It's probably because our Word is not the same version. If that makes sense. Just some technicality. Anyway, so let's look at the problem. All right, first one, fairly straightforward. You're looking at FGJ, which is FGJ is here. Then you just use the inside angle formula because the arc that's cut is here and here. So it would be what? 1/2 31 plus 52, which is going to be 41.5. Is that right? Okay, so that's the first one. And the second one, it's HJK, which is this tangent angle that's related to this arc right here. So it's going to be half of that. So 130 over 2 is going to be 65. Okay, that's the first question. How are we doing? Is that okay? This is the most straightforward problem out of the 4. Okay with that? Just straight up applying the theorem. Okay, so we're going to move to the right side then. So this problem is more complicated because initially you want to find this arc X measure, but you're missing a lot of parts. So what I'm identifying immediately is this X kind of is related to this angle right here, right? Like outside angle. So you need two arcs. You need this arc, and this angle. This arc I already know is 25 plus 85, so that's 110. Okay? I don't know this arc. And I don't know this angle yet. But I need to find this angle to find this arc. Okay? To find this angle, take a look at this triangle right here. This one. See it? This triangle. How are this triangle related? This angle, this angle, this angle should add up to... Do you guys like all froze, or you like forgot to talk? Oh, okay, I got you guys. So these three are add up to 180, so you got like 180 minus 48 minus 83, which end up being what, 49? Is that right? Because this is like 131, right? 131, 49 degrees. So this here is 49 degrees. Now you can use the setup. 49 is an outside angle, is equal to half of this minus that. Okay, 49 equals half. 110 minus x. Right, 110 minus x. Because outside angle is equal to the difference between these two divided by 2. Okay, so 98 equals to 110 minus x. So x is equal to 12 degrees. Okay, that will take care of that. How's it going? Do we understand number 2 now? Once you see it, it's much easier, right? But if you don't see it, then it's hard. This is very experience based, basically. So you just have to do more. Okay. All right. The bottom 2 is also interesting. So if you look at the bottom 2 questions, so the first one is they want to find LP, which is this one. So let's make it X, okay? Because we want to find this arc. Okay. So to find this arc, I look at this angle and this arc, because this angle is 26. I don't know this arc. All right. Once I find this arc, because I know LR is 100, so once I get this one, I can just subtract from 100 to get X, right? Because LR is 100, right? So to find LP, I just need to find PR, and then I'll get it. Why do I want to find PR? Because the only relation that I got here is from this angle right here, right? This angle. I'm gonna use that, okay? All right, so 26 is equal to 1/2 this minus that, right? 80 minus y, which end up being 52 equals 80 minus y. So y is 28 degrees. All right. Once you get that, then LP x is equal to 100 minus that, because the whole thing is 100 minus 28, which will end up being 72 degrees. Oh, sorry, you can't see. Let me move it down a little bit. So once you get, measuring measure arc LP will be 100 minus 26. Okay, which will be 72. Should I slow it down, or we're still okay? All right. So last part, measure angle YZ, which is here. Measure arc YZX here. So you're looking at this arc. So you kind of want to find this arc if possible, right? So there are many ways to do this problem, okay? One of the ways you can look at is, okay, I kind of want to find this and this so I can do the averaging and I can find X because I already know 113. That's one of the ways to think about it. Okay. Now, any concern about this one though? Okay. So, it's too long. What does that mean? Okay. So, let's look at this instead. So, can I find this angle? What's that angle? The one I just marked. Hmm. 67 here, right? So since this is 67, can I find this arc right here? Let me change the. Can I find this arc? What would this arc be? Wouldn't this arc be, let's call it Y, okay? Isn't this related to this angle? So average of these two will give you this, right? So that means what? Half of y plus 68 should equal 67, which y turns out to be 66. How did I do that so fast? Because, look, 67 is supposed to be average of 2, so this is 68, of course this is 66. There's a middle. That's called the middle, right? Alright. Now, once you find this, hey, you have this, and you can look at this. Here, look at this angle right here. This is now the outside angle. You have this arc, and you want to find this arc. So now you can use 49 equals outside angle formula 1/2 x minus 66. Which is 98 equals x minus 66. So x turns out to be, oops, 164. Is that right? So once again, in the beginning, I'm not sure which direction to take. So the way I did it was I look at this. Who's Michael Schiffer? Anyway. Anybody know this guy? Anyway, so let me see. I think people are going crazy because they are what's that called? Okay. Goodbye. Wait, that doesn't make sense. Let me I know. Like, I don't even know who this guy is. Report. Alright. I already did it. I know, right? Whoever this guy is. Alright, anyway, are we okay with this? The problem? So we didn't know what to do at first, so all I did was Michael. Anyway, so this we don't know what to do, so we just basically find any angle we can. So we got an angle here, and once we get this angle, we can relate it to these two arcs. And once I get these arcs, then I can find this. Okay. All right. So probably a troll. It's definitely a troll. Okay. All right. So So, what is due this Friday? So, if you go on your Schooloop, let me show you something. Oops. Okay. So, if you go on your Schooloop, on your calendar, you should have an assignment somewhere down this Friday. So click on that, okay? Then you will see what is due. So there 10.4 practice, which is what I gave you before, which is the one that I just did. If you didn't receive this, this is also in the note guide in Locker. 10.5 notes is what we did today. And 10.5 homework is what's listed in the below. What we're gonna do is you have a submit button, but you don't have submit. You don't have a submit button, but you have next to submit, you have two options. Okay, one says device, one says locker. Usually, you click on device and you upload your photo copy of these things. So you just take a photo of all these assignments and then you just upload it there. Okay, that way you can get grades. Any questions about this? Once again, this is under your calendar or assignments. Under this week's assignment, this is due Friday. Click on it, and then it will tell you what's due. And submit, next to submit, there are two options, device and locker. Click on device and upload your photos. Does that make sense? Nobody said anything. Okay. I take it that it makes sense. All right. So that would be basically the lesson. It's today Thursday. Yeah, it's due end of day tomorrow, so you can just do the homework today. Okay. Tomorrow you don't have class, is that correct? So you have a lot of time. All right. Any other questions before we go? End of the day meaning like before 12 o'clock? Yes. The picture of notes, chapter 10.4, and the homework. Zero to zero power is a good thing to think about. All right. All right. Anything else? Goodbye. This is the remix of the music I have with the Kahoot. Can you hear the Kahoot in the background? Goodbye.